Hello everyone, this is Sachin Manandar and this video assignment is on information retrieval. So this project demonstrates a complete pipeline for retrieving, searching and classifying documents. So it consists of four major components. The first one is creating web crawler for data collection from pure portal of Coventry University specific to School of Economics, Finance and Accounting. So it contains total of 770 documents and 7 profiles. So we have to develop a crawler for this particular site. And then second one is to create a search engine using TF, IDF and cosine similarity for creating a search index and to develop a search engine based on that. The third one is to create a document classification model with naive Bayes model. So then after that, so we have created RESTful APIs which we have integrated in our user interface. So let me go thoroughly through each and every individual tasks. So now let's start from the task one, developing search engine and web crawler. So we have implemented a polite web crawler in Python using Selenium package. So it collects all the research outputs from Coventry University School of Economics, Finance and Accounting. So the crawler respects robots.txt and introduces a minimum of 5-second delay between requests. So this particular file crawler.py contains all the so we have created a particular class Coventry publication crawler, so which crawls all the data from that particular site, and the response and output is saved as publications.json. So then after they creating a search engine, so after creating a crawler we have developed a search engine based on the TF IDF based search engine. So to execute the particular search engine, so we have developed API using fast API, and we have also documented the particular API. So if you see, we have developed different APIs based on different tasks. Now specific to source engine. So if I query anything, let's say documents from Asia, so it will uh, create a index from user input, and it ranks based on the TF IDF vectorization and provide a result based on that. So we have also developed UI for that particular model or search engine. So we have integrated that particular API. Now let's say learning from town, so it will sort based on that. We can we can sort the particular documents based on title, date, authors, and we can also set the number of results we want to. So now for the third part, we have collected different documents from different sources and categorized in mainly three part: the politics, business, and health. So we have collected for each categories 35 documents, and those documents we had split it in 80/20. For training dataset we have used 80 percentage of dataset, and for training we have used 20% of datasets. And the particular document classification model also creates a confusion matrix that has displayed around accuracy of 74.19%. So then that particular model is run through the fast APIs that we have document in the Swagger UI. So now going towards the demo, so we have then integrated that particular API in our user interface. So users just have to users just have to press train model, and then that particular model is trained and confusion matrix is plotted, and based on this information user can now classify the documents. For example, let's say people can people are more careful in physical health after COVID. Now if the classification model is right, it should provide the title category related to health. Now if you see, so it has predicted the health category. Now similarly, let's go for another example: international trade agreements about to happen. So if it is right, now it should predict related to business. So yeah, it has predicted right. Okay, so then all the tasks are documented in this particular document that will be submitted further, and then this video will be posted in YouTube.